All right, so like I mentioned, we have several types of chi-square testing. So you see, we've looked at hypothesis. In a situation where you are doing a statistical test to confirm whether the null hypothesis is true or false, or the alternative hypothesis is true or false, then we say you are doing hypothesis testing. So hypothesis testing is basically a statistical test to confirm whether null hypothesis is true or alternative hypothesis is true or false. Okay? Now, the types of hypothesis testing, we have chi-square test, we have t-test, we have z-test, we have correlation coefficient, we have ANOVA, which is analysis of variance, we have regression. Okay, so we have several types or examples of hypothesis testing. So these are all examples of hypothesis testing. Now, in this video, we are going to look at the chi-square test, how to do chi-square test in statistics. Okay, so the topic we are going to look at is chi-square test. Now, what is chi-square test? What is a chi-square test? Chi-square test is basically a type of hypothesis testing or a statistical test used to check the relationship between two categorical variables. Okay, so we use chi-square test to actually check the relationship between two categories. The underlined word over here is categorical variables or qualitative. Categorical variables or qualitative variables. So if you want to do a statistical test to measure the relationship between two categorical variables. So for example, if you have smoking and lung disease, categorical variable, a variable that does not come in the form of a number. Any variable that if I should request from you, the response that I will get will not be in the form of a number. For example, smoking status. Your smoking status is either you're a smoker or a non-smoker. In practically, a smoker is not represented by any number. So any variable that if you are requesting from someone, the response will not be in a number form. That variable is a categorical variable or a qualitative variable. So for example, smoking status is a categorical variable because your status will not be represented by any number. Lung disease is either you have lung disease or no lung disease. So it's also a categorical variable. Now in a situation where you have two categorical variables and you want to measure the relationship between them, we use chi-square test. So chi-square test is a statistical test used to measure the relationship between two categorical variables. For example, smoking and lung disease. Or you want to look at the relationship between learning for long hours and passing exams. Learning for long hours and passing exams. These are two categorical variables. Okay, if you want to look at the relationship between these two, we can do chi-square test. If you want to look at the relationship between sleeping late and then, let's say, hypertension. You see, these are all two categorical variables. Okay, so if you want to look at the relationship between the two, we can do chi-square test. So if we ask you that, what type of hypothesis testing can we use to check the relationship between two categorical variables. That is chi-square test. Now let's look at an example of a chi-square test. So usually chi-square test, this is how the question will be presented. This is how we present question in chi-square test statistic. So this is how the table will come. Okay, and you need to understand the dynamics of the table or how the structure of the table looks like. So you see, we have the variable over here. So we have one variable here, exercise. We have another event or variable over here, obese, not obese. Okay, so for exercise, we have regular exercise, no regular exercise. Obese, we have what? Obese, not obese. So you see, in this test, it's like we want to look at the relationship between exercise and obesity. Okay, and in chi-square test, we will always give you the two variables. We want to look at the relationship between exercise and obesity. Is that okay? So we want to look at the relationship between exercise and obesity. Is that okay? So look at how we interpret the table. Okay, so we see we have regular exercise. People who engage in regular exercise who are obese, they are 21. People who engage in regular exercise who are not obese, they are 29. People who do not engage, no regular exercise, who are obese, they are 24. No regular exercise, who are not obese, they are 29. That's what the table is telling us. Now, you have to complete the table. Usually, when we give you a table like this, make sure the table is complete. How do we complete the table? This part of the table is there's the column. This is also a column. This is a row. This is also a row. So let's do the column total. So here is a column total. This part is also a column total. So if you want to get this total, 21 plus 24, that will give us 45. If you want to get this side, this is 29, this is 29. So the total will be what? Come again? 58. Now, if you want to get the row totals, you have to add this 21 to 29. You add this 21 to 29, you get what? If you want to get this row total, you add this 24 to what? 29, you get 53. Okay, now if you want to get this part of the table, we call it the grand total here. We call it the grand total. If you want to get the grand total, it's two things. Either you add this column total to this column total, or you add the row totals. So either you add this 45 to 58, what are you going to get? 103. Or you can add this 50 to 53 to that one, so you get 103. Remember, you don't have to add this and this. Keep the answer and come and add this and this, and you add together. No. It's two things. Either you add this 50 to 53, you get 103. Or you add the 45 to 58, you get the same 103. And all the time, when you do it correctly, it should balance. If it doesn't balance, it means the table, you are having a problem with your calculation. So when you add this 50 to 53, you should get 103. If you add this 45 to 58, you should get 103. If you do it all the time and it does not balance, it means there is a problem with the table. Is that okay? So remember that the total over here, we call it the column total. The total over here is also called column total. Now, these ones are the rows. So here we have the row total. This is also a row total. And this is what we call the grand total. Okay? Good. Now, let's start with the calculation. Now, chi-square test in statistics involves 8 steps. Chi-square test in statistics involves what? 8 steps. Okay? So chi-square test in statistics involves 8 steps. Now, the first step the process of solving chi-square test in statistics involves 8 steps. Now, the first step, we call it, you state your hypothesis. And remember, we learned that in hypothesis, you always have to state 2 hypotheses. So when you get over here, the step 1 is very simple. we've given you two variables. The variables will always be stated in the question. So for example, this question, the statement on the question is that a public health officer wants to test the relationship between exercise and obesity. That's the question. A public health officer wants to check the relationship between exercise and obesity. And they are asking us to test at 5% significant level whether there is a relationship between exercise and obesity. So you see, that statement would always be given to you in the question, the variables you are checking. The step one, you state your hypothesis. How do you state the hypothesis? We learned that we have two hypotheses. So you write null hypothesis. Step two, alternative, then the alternative. So you are going to state two hypotheses, the null hypothesis and the alternative hypothesis. Now the null hypothesis, what does it say? What are the two variables, exercise and obesity? You are just going to write, there is no relationship between exercise and obesity. Simple. There is no relationship between exercise and obesity. Alternative hypothesis, you are just going to write a statement. There is a relationship between exercise and obesity. There is a relationship between exercise and obesity. Now, this is what we call the first step, step one. So the step one, you state your hypothesis. Okay? Step one simply means you state your hypothesis, and we learned that we have two hypotheses, the null hypothesis and the alternative hypothesis. What is the null hypothesis? There is no relationship between exercise and obesity. What's the alternative hypothesis? There is a relationship between exercise and obesity. But remember, someone will ask that, where did we get the exercise and obesity? You see, these are two variables. All the time, the variables will be given to you in the question. So in this example, the variables that we are having exercise and obesity. So the step one, you are going to write your null hypothesis. There is no relationship between exercise and obesity. Alternative hypothesis, there is a relationship between what? Exercise and obesity. Now let's move on to step two. Let's move on to step two. Step two, you determine your degree of freedom. You determine your degree of freedom. Now, how do you determine your degree of freedom in hypothesis testing? So the step two, you determine your degree of freedom. How do we determine degree of freedom? Now, degree of freedom, there is a formula for degree of freedom. df is equal to rho minus 1, close the bracket, open the bracket, c minus 1. So df is equal to rho minus 1, close the bracket, open the bracket, call u minus 1. R simply means R is equal to number of rows. And then the C is equal to number of columns. Okay? Now, how will you get the number of rows? How will you get the number of columns? Let's go back to the table. You see, in the table, let me show you how to interpret this table. Now, in this table, this part of the table is actually not part of the table. It's just showing the variables. This part of the table is just showing you the event. And where we have the totals is not part of the table. Where we consider part of the table is where the frequencies are. This area here. So this is actually the table itself. This area is actually the table here. Where I'm moving around. This is actually the table itself. Okay? So now, how do you get the number of rows? So you see we have row 1, and then we have row 2. So we have 2 rows. So the rows are equal to 2. How about the columns? We have column 1, and then we have column 2. So what that means is that we have 2 rows and 2 columns. Okay? So we have 2 rows, row 1, row 2. 2 columns, column 1, column 2. Okay? So we have 2 rows and 2 columns. Okay, so the actual table is where we have the frequencies, and these are the frequencies. So the totals are not part. And then the totals down here too are not part of the table. So the actual table is this, where we have the exact frequencies. So we have row 1, row 2, column 1, column 2. So it means we have 2 rows. The number of rows are 2. The number of columns are also 2. Now, if you want to calculate df is equal to rows are 2 minus 1. Columns are also 2 minus 1. So df is equal to 1 times 1. That will give you 1. But now, apart from this, there is a principle in statistics. Statistics always make things very simple for you. Now, the principle is that anytime we give you a 2 by 2 table, the df is automatically equal to 1. So you can state the principle, or you can go by the formula. Anytime we give you a 2 by 2 table, and this is a typical example of a 2. Why do we call it a 2 by 2 table? 2 by 2. All the time when you hear 2 by 2, the first one represents the row, the second one represents the column. When you hear 2 by 3, it means the rows are 2, the columns are hot. The row is 2, the column is 3. When you hear 4 by 5, what it means is that the row is 4, the column is what? 5. That's the meaning. So when you hear 2 by 2, it means the row is 2, this is the row, this is what? The column. When you hear 3 by 5, it means rows are hot. This is the row, and this is the column. That's the meaning. Okay, so for a 2 by 2 table like this, so this is a 2 by 2 table. Why 2 by 2 table? Rows are hot, 2. Columns are hot, 2. So for a 2 by 2 table, anytime we give you a 2 by 2 table, the df will automatically be 1. So instead of even writing the formula, you can go straight and write. For a 2 by 2 table, df is equal to 1. Simple as that. Again, you can also state the formula. df is equal to r minus 1, close the bracket, c minus 1. Then you do the r is what? R is 2. And we can give you an MCQ question. And we tell you that, okay, John is calculating chi-square tests on a 3 by 5 table. Calculate the df. Calculate df. Then you write. Remember this one, once you hear 3 by 5, the first one is a row, the second one is a column. So df will be equal to r minus 1, c minus what? 1. df will be equal to r is what? 3 minus 1 into bracket 5 minus 1. This will give us 2 times what? 4. This will give us what? 8. So df is equal to 8. Is that we can give you that in MCQ. And they can also specify that someone is calculating, doing chi-square test. The number of rows is what? 2. The number of columns is 4. You see that one, they've specified. But if they don't specify, they say 3 by 5. You should know that the first one is the R, the second one is what? The C. So when you get over here, you can use the principle. Once you know the table is a 2 by 2 table, the principle is that df will always be equal to what? 1. You state the formula, but I think I will advise you, if you learn the formula, it helps. It makes life very easy. Is that okay? And if you also want to go by the principle too, that is also fine. Now, and this is the only thing you do in the step 2. So once you do this, you are done with the step 2. Now let's go to step 3. Step 3, you determine or you state your significance level. You state your significance level. Now, the significance level will always be given to you in the question. Usually, they will write it under the table or they will write it within the question statement on top of the table. So they will write test at 5% level of significance. Once you see test at 5% level of significance, what it means is that the significance level is 5%. Sometimes they will write test at 95% confidence level. That one also means the significance is 5%. Sometimes they will write test at 2% level of significance. Sometimes they will write test at 98% confidence level, meaning the significance is 2%. All the time, they will give you the significance in the question. Now, if they tell you test at 5% level of significance, you write significance into brackets alpha is equal to 5 over 100. And 5 over 100 is 0.05. This is what you do. Once you do this, you are done with step 3. And this is the only thing that you do in step 3. This is the only thing that you are expected to do in step 3. So step 3, you state your significant level. How do you get a significant level? It will be given to you in the question. Sometimes they will write test at 95% confidence level. Once you see test at 95% confidence level, it's the same as the examiner telling you test at 5% significant level. And once you see test at 98% confidence level, it's the same as the examiner telling you test at 2% level of significance. Once you see test at 99% confidence level, it's the same as the examiner telling you test at what? 1% level of significance. Is that so? We are done with step 3, state significance level. Let's move on to step 4. Step 4, determine critical value. Determine critical value. Now, in the step 4, you will need step 2 and step 3. The step 2 is where we determined the degree of freedom, and the step 3 is where we determine the significant level. So in the step 4, you are going to determine the critical value. How do you do that? You are simply going to write if df is equal to the df, what did we get? We had 1. And alpha is equal to, what did we get for the alpha? We had 0.05. Then now you move straight with this. You now move straight to the chi-square distribution table. So now let's take the chi-square distribution table. Okay, so you go to the chi-square distribution table, and this is how the chi-square distribution table looks like. So this is a typical example of the chi-square distribution table. Okay, so when you get to step 4, determine critical value. If df is equal to 1 and alpha is equal to 0.05, then now you come straight to the chi-square distribution table. On the chi-square distribution table, you see we have the df on this column. This is where we have the df. And this is where we have the significance level. Now check, the significance is 0.05 here. Significance is 0.05. And then the df is equal to what? 1. So you match where the df1 meets the 0.05, and that is 3.841. So it means that your critical value, so if df is equal to 1 and alpha is equal to 0.05, if df is equal to 1, alpha critical value will be equal to 3.841. Let's assume that the df was 5. Let's assume df was 5 and alpha was 0.02. Let's do this example. Let's assume df is what? The df is 5 and alpha is 0.02. This is 0. Df is 5, alpha is 0.02. That will give us 13.39. 13.39. And we can ask you a question in statistics that, okay, on the chi-square distribution table, what is the critical value for df14 against alpha 0.2, df14 against alpha 0.2. So DF 14 against 0.2, that is 18.15. We can also ask you, okay, on the chi-square distribution table, what is the critical value for DF8 against alpha 0.025? So DF8 against alpha 0.025. You see, that is 17.54. 17.54. Is that okay? Those are some questions that you can be expecting in multiple choice questions. And so you need to know how to identify the critical value given the DF and the alpha. So now, step 4, determine critical value. How do you determine critical value? You use step 2 and step 3. Step 2 is where you determine the degree of freedom. Step 3 is where you determine your significant level. So if DF is 1 and alpha is 0.05, then you go to your chi-square distribution table to get a critical value. And for our DF and significance, we had a critical value of 3.841. Now, the moment you finish doing this, you move on to step 5. Now, with step 5, you calculate your expected frequencies. You calculate your expected frequencies. Now, in step 5, we have a formula over here. So, expected frequency is equal to rho total multiplied by column total divided by what? Grand total. Now, when you get to this step, you have to redraw another table. But I'll show you a trick in drawing the table. Okay, when you get to this step, you are expected to draw another table. Now, on that table, you are going to remove the totals from there. Okay, it's like you are redrawing the table again, but you are taking away the total. So this is how it's going to look like. We are going to have regular exercise. We are going to have no regular exercise. Then we are going to have obese. We are going to have not obese. So you see, on this table, we've taken away all the totals. Now, how do we calculate the expected frequencies? You are going to use the original table that was given to you in the question in calculating the expected frequencies. Now, if you want the expected frequency for this 21, the formula says row total. The row total is 50. The column total is 45, divided by the grand total. So if I want the expected frequency for this, its row total is 50. Column total is 45. Then I divide by this 103. If I want the expected frequency for this 21, the row total is 50, divided by the column total 45. Sorry, multiply by the column total 45, divided by 103. So this is actually, if I want for the 21, the row total is 50, multiplied by column total is 45, divided by the grand total is what? 103. Then you compute the answer. Quickly compute the answer for me. Now, how are you going to get the expected frequency for 29? It's 50 multiplied by what? 58 divided by 103. How did we get that? The 29, the row total is 50. The column total is 50 divided by 103. Let's come to the 24. What is the row total? 53. So 53 multiplied by, what is the column total? 45 divided by grand total 103. So the grand total will never change. That is one trick. The grand totals are going to be the same for all of them. Now, if you want the expected frequency for 29, what is the row total? 53. Multiplied by, what is the column total? 58. Divided by grand total 103. The grand total will always remain equal for all of them. You always have to take note of that. So now, compute this. Give me the first answer. 21.845. The second answer? 28.15. The next? 23.15. The next? 29.845. So now we are done with the expected frequencies. Now when you finish with the expected frequencies, here this is where you end. Once you do this, you are done with the expected frequencies. Then you move on to step 6. The step 6 calculates chi-square test statistic. You calculate chi-square test statistic. Now, over here too, we have a formula. S squared is equal to big sum of observed minus expected, close the bracket, all squared, all over expected. So when you get over here, this is the formula that we are going to use. Okay? S squared and the chi-square, we represent it by capital S squared. So chi-square is equal to big sum of observed minus expected, close the bracket, all squared, all over expected. So after stating the formula, over here too, you are going to draw another table. Now in this table, now remember when we started, I told you that this table is actually showing 4 things. Now on the second table you are going to draw, you are actually going to draw a table that will show us all the 4 things at a glance, at once. So the table is showing 4 things, but this is how we look at the things. So you see, regular exercise, people who do regular exercise who are obese. So regular exercise, obese. Regular exercise, not obese, that is 2. So regular exercise, comma, obese, that is 1. Regular exercise, comma, not obese, that is 2. No regular exercise, people who do not regularly exercise who are obese, that is 3. People who do not regularly exercise who are not obese, that is 4. So you come and write. You are not going to write anything from your head. You just write regular exercise, comma, obese. So like this, regular exercise, comma, obese. That is 1. The second one, regular exercise, not obese. Comma, not obese. Then the third thing the table is showing, no regular exercise, comma, obese. Then the fourth thing the table is showing, no regular exercise, comma, not obese. So you can see clearly that the table is basically showing 4 things. Now, on the second table you are drawing, you just want you to draw a table where we will see the 4 things at a glance. When you finish drawing the table, writing the elements we have in the table, draw a line like this. So here, write O over here, here write E. Then here you write observed minus expected, close the bracket, all squared, all over E. Now, to complete the O part, you go back to the original table. The original table the examiner gave you in the question. Regular exercise, those who do regular exercise who are obese, how many are they? They are 21. Then you write 21 over here for the observed. Now remember, the original table the examiner gave you, we call it the observed frequency table. Okay? Now, people who do regular exercise who are not obese, they are 29. You come and write the 29 over here. No regular exercise who are obese, they are 24. No regular exercise obese, they are 24. No regular exercise not obese, they are 29. You write the 29 over here. Is that okay? Then now you come back to the expected table. That is what you use to fill the E. Now, regular exercise who are obese, we had 21.845. 21.845. Regular exercise who are not obese, 28.15. No regular exercise who are obese, we had 23.15. The last one, no regular exercise who are not obese, we had 29.845. Okay, so now you see, so it's like, we are now having one table, a single table, with the observed from the examiner and the expected that we calculated all on the table at once. That's how the second table is supposed to be. Then now you come and interpolate them into the formula. So observe, so the capital S squared, observed minus expected, close the bracket, all squared, all over E. Is that okay? So here, the observed for this category, regular exercise who obese, for this category, observed is for 21. So we have 21 minus expected is for 21.845 squared divided by 21.845. Then you write the answer. Then you come to the second one, 29 minus 28.15, close the bracket, squared, all over 28.15. Then you come to the second one, O is 24, minus 23.15, all over 23.15. So here, squared. We write the answer. 29 minus 29.845 squared, all over 29.845. So compute and give me the answers. 0.033, 0.0254, 0.0308, the next 0.0239. So these are the answers we are getting. Now when you get these answers, the formula says sum of, big sum of. So what that means is that you are coming to sum all this. So you write capital S squared is equal to 0.033 plus 0.0254 plus 0.0308 plus 0.0239. So this is it. So you sum all the figures that you've gotten here, then you get the capital S squared, which you stated as the formula. Okay, so in the end, what are we going to get? 0.113. 0.113. Okay, then now we move on to step 7. Step 7 is decision rule. Now, in chi-square test, there are 2 decisions. Decision rule 1. If calculated chi-square is greater than critical value, reject H0. Decision rule 2. If calculated chi-square is less than or equal to critical value, fail to reject H0. So now our calculated chi-square, what did we get? Our calculated chi-square, what did we get? 0.113. So that means that you write S squared into bracket 0.113 is less than, right? It's less than critical value. What did we get for the critical value? 3 point. It's less than critical value into bracket 3.841. Then you are done. So this is how you end the step 7. So the step 7, you first of all state the 2 decisions. And please remember, with the step 7, mandatory, you have to state the 2 decisions. Now in chi-square test, there are 2 decisions. They are saying that if you calculate, and your calculated S squared, this one, the calculated chi-square, or the chi-square test statistics, if it is greater or bigger than your critical value. The critical value is what you determine in step what? Is it 5 or 4? Step 5. The critical value is what you determine in step 5. So if your calculated chi-square, this one, the answer, is greater than the critical value, reject the H0. The H0 is your first hypothesis, the now one. The decision rule 2 says that if your calculated chi-square is less than or equal to critical value, fail to reject, meaning accept. And remember I told you we don't use the word accept. That's why the decision rule is placed like that. So when we say fail to reject H0, it means accept H0. But here, our calculated chi-square, we had 0.113. And this 0.113 is smaller than the critical value. It means we fulfilled decision rule 2. What that means is that we have to fail to reject H0. So in the conclusion, you just write step 8. Conclusion. Then the step 8, you just copy the null hypothesis there. You not think about anything. No. You see, because you see the decision says if calculated chi-square is less than or equal to critical value, fail to reject H0, meaning accept the H0. So in your conclusion, you just copy the null hypothesis. The null hypothesis, what did we write? Therefore, there is no relationship between exercise and obesity. Simple as that. You are done. Is that okay? So in the step 7, that is the decision rule. How many decisions do we have in chi-square? There are 2 decisions. If the calculated chi-square is greater than critical value, reject H0. If the calculated chi-square is less than or equal to critical value, fail to reject H0. Then now you go back to your step 6. What did you get for the S squared? 0.113. Okay, then you go back to your step 5. What did you get for the critical value? 3.841. Now, our calculated chi-square is small. You see here, our calculated chi-square is smaller than the critical value. That means that we fulfill decision rule 2, which says that if calculated chi-square is less than or equal to critical value, fail to reject H0, meaning null hypothesis is correct. Then step 8, you just write step 8, conclusion. Then you repeat the exact thing you wrote for the null hypothesis. Therefore, there is no relationship between exercise and obesity. Let's assume that in the step 6, we had, let's say, 5.6. You see, if we had 5.6, you know 5.6 is greater than what? The critical value of 3.841. So in this situation, it means we will fulfill decision rule 1. If calculated chi-square is greater than critical value, reject H0. So in this situation, it means that we would accept alternative hypothesis, but we don't use the word accept. So you say reject H0. When you say reject H0, it means you've accepted what? You've accepted reject H0. It means you've accepted the alternative hypothesis. Then you go and write, therefore, there is a relationship between exercise and obesity. So assuming our answer was this, 5.6. 5.6 is greater than this. So it means we will fulfill decision rule 1. If calculated S square is greater than critical value, reject H0. That means we will go in for alternative. Then you go to the conclusion and write, therefore, there is a relationship between exercise and obesity. So this brings us to the end of chi-square test in statistics. Thank you. Sammy, this example, I think, is the